We are doing quantity of heat, second part. That is nothing but the calorimetry. In this, our objective is to write and apply the formula for calculating latent heats of fusion and vaporization of various materials. So, when there is a change of phase, what is going to happen? When a change of phase occurs, there is only a change in the potential energy of the molecule. The temperature will be constant during the change. Like you see here, when a solid is converted to liquid, which we call as a fusion, there is a solid state to liquid state at constant temperature. Suppose if you take an example of ice and water, ice melts at 0 degrees centigrade. Whatever the heat energy you are supplying, it is only a converting at the same temperature from ice to water. Temperature is not changing. But if you see the molecular structure there, in the solid state molecules are closer. In the case of liquids, the molecular distance is increasing, that is potential energy is increasing. And temperature is constant, therefore kinetic energy is not changing. That is called change of phase, solid state to liquid state. And this L is called latent heat of fusion. Now we are discussing about liquid to gas or vapor. If you are further heating the liquid, suppose if I take water at 100 degrees centigrade, if I heat it further, there is no rise of temperature, but we find the steam is prepared. That is, vaporization is taking place. That is, water is becoming a gaseous form. So, there is a change of state further. So, in the liquid state, molecules, if you see, they are little closer. But in the case of gaseous system, molecules are going farther and farther. That is, the molecular structure is changing. That is, potential energy is increasing. But what is the temperature for the case of water? It is only 100 degrees centigrade. That is, kinetic energy is not changing. So, when there is a change of state, only potential energy changes, temperature will be constant, and there is no change in the kinetic energy of the system. And that type of change of phase we are going to discuss. And in the case of this liquid to vapor, we call latent heat of vaporization, L suffix V. So these are the different forms of latent change of phase, like fusion, vaporization, condensation, latent heat, evaporation, freezing point, melting point. All these are nothing but taking place from one state to another state at constant temperature. So, what is latent heat of fusion? The latent heat of fusion of a substance is the heat per unit mass required to change a substance from solid state to liquid state or solid phase to liquid phase of its melting temperature. That is, at a melting point, there is a change of state is taking place from solid to liquid. This is called latent heat of fusion, L suffix F. It is equal to Q by M because Q is equal to M into L. So, there are only two formulas in the quantity of heat, that is nothing but change of state. That is nothing but in the case of calorimetry, one is Q is equal to MC delta T when there is a change of temperature. There is another formula Q is equal to ML when there is a change of phase. In this case, latent heat of fusion for water, L suffix F, 80 calories per gram for water. What is MKS unit of this one? 3.36 into 10 power 5 joule per kg. In a similar fashion, when the liquid is changing from liquid form to vapor form, it is called latent heat of vaporization. The latent heat of vaporization of a substance is the heat per unit mass required to change the substance from liquid to vapor state at its boiling temperature. So that is If you take water, it is at 100 degrees centigrade. This phenomena is going to take place from liquid to steam. That is nothing but vapor. So that is called latent heat of vaporization. Similarly, the formula for L suffix V is equal to Q by M. Q is the quantity of heat energy supplied. M is the mass. Latent heat of vaporization of water is 540 calorie per gram. Here we are taking an example how much heat is needed to convert 10 grams of ice at minus 20 degrees centigrade to steam at 100 degrees centigrade. Here it is ice at minus 20 and steam at 100, and first we want to take a graphical method to understand various phases in this process. So you see here it is minus 20 to 0 degrees centigrade. When you are supplying the heat energy to rise, there is a change of temperature, but still it is in the ice form. When there is a change of temperature, formula is mc delta T. So here the specific heat of ice is 0.5 calorie per gram degree centigrade. Now, if you are further heating, what is going to happen? That ice is melting, and here latent heat of fusion of ice is how much? 80 calorie per gram. Ice at 0 is melting and giving water at 0 degree centigrade. It is water at 0 degree centigrade. Now if you further give the temperature, then this water at 0 is converted to water at 100 degrees centigrade. There is a change of temperature. The formula is mc delta T, and the specific heat of water is 1 calorie per gram per degree centigrade. Now if you further give temperature the water at 100, it becomes a steam at 100 degrees centigrade, and the latent heat of vaporization of water is nothing but 540 calorie per gram. We know that. So these are the different states as you are supplying the heat energy to the ice block at minus 20 and to become steam at 100 degrees centigrade. How many grams of ice at 0 degrees centigrade must be mixed with 4 grams of steam in order to produce water at 60 degrees centigrade? You are mixing ice at 0 degrees centigrade and steam also at 100 degrees centigrade, so that we can have water at 60 degrees centigrade. I am taking the diagram here labeled. The ice must melt and then rise of temperature should be 60 degrees. Steam must condense and drop to 60 degrees. We have to calculate. Total heat gain should be equal to total heat lost. So in the case of ice we have written, in the case of steam also we have written both sides, and we are going to write. If you write the values, total heat gain should be equal to mass of ice we require 80 calories, latent heat of ice plus mass of ice we have to calculate. The specific heat of water is 1, change of temperature is 60 and 0, therefore 60 minus 0 degrees centigrade. Heat lost, it is nothing but now ml we have to write. The mass of the steam is given as 4 grams, 4 into latent heat is 540 plus steam mass is 4, specific heat is now already converted to water form 1, change of temperature is 100 minus 60. So if you simplify that, you are going to get the values like this. It is equal to mi, mass of ice required is nothing but 2320 by 140 grams. If you simplify, it is coming as 16.6 gram. This is the method of doing the problems, various problems. With these inputs, you can solve any type of problem in calorimetry. One is change of temperature, another is change of state. Here we are taking another example. 50 grams of ice is mixed with 200 grams of water initially at 70 degrees centigrade. Find the resultant temperature or equilibrium temperature of the mixture. So we labeled the diagram and how to calculate. There is heat gain by this water and heat gained by ice. Here we have to calculate heat gain we calculated here ml plus mc delta T, and here mass is given as 50, latent heat of ice is 80, and it is water specific it is 1, and change of temperature is always higher minus lower. TE nothing but equilibrium temperature or resultant temperature minus 0, and if you calculate it is nothing but equal to heat lost by water. Just there is only change of temperature for water, it is 70 degrees centigrade, and resultant temperature is TE. And if you equate these two things, so when I am equating these two things, simplify, we can calculate TE value. So TE is equal to 10,000 by 250, it is equal to 40 degrees centigrade. So the resultant temperature is 40 degrees centigrade. So verify the calculations carefully here. So what is the summary? Change of phase we are discussing. The latent heat of fusion of a substance is the heat per unit mass required to change the substance from solid to liquid phase of its melting temperature. In the case of latent heat of fusion of water is 80 calorie per gram or 3.36 into 10 power 5 joule per kilograms. What is the formula for latent heat of fusion? Q by M. Q is the quantity of heat, M is the mass. Now, what is the latent heat of vaporization of a substance? Is the heat per unit mass required to change the substance from liquid to a vapor form at its boiling temperature. In the case of water, its value is 540 calorie per gram, and the formula for latent heat of vaporization is Q by M. Q is the quantity of heat, M is the mass. And if there is a change of temperature, I am saying always the formula is Q is equal to MC delta T, or C is equal to Q by M delta T. If there is a change of state, then the formula is Q is equal to ML. And if it is vaporization, we write LV. If it is a fusion, LF. So only two formulas here, change of state and change of temperature. So change of temperature, MC delta T, change of state, ML. Here it is obeying law of conservation of energy. And when there is no losses, then the heat lost by a body is equal to heat gained by other body. So sum of the total heat loss is equal to sum of the total heat gained by the system, and when it is completely insulated.